Hi, good evening. My name is Miss Daniela McGilvery. Welcome to another CSEC IT paper review. I will be looking at some questions specifically from problem solving as well as productivity tools, zeroing on database management and spreadsheet. So let us begin. All right. So what I've done is compiled a few questions from several past papers, as you can see, 2025, 2017, quite a few. So we're going to start with this question here. Consider the following database with two tables named farmers and farm. So as you can see, we have the two tables here and we have the different fields in the tables. So when you look at the farmers table, you can see the ID number, the first name, the last name, the gender, contact number, as well as region. When you look at the farm table, you're going to see the farm ID, crop, cost per produce, as well as the farmer ID. So these are the two tables that contains several records. So the first thing that you need to do is look at your table and ensure that you understand the data that is presented in your table. The first question states, in the database table, farm, name the field by which each record can be uniquely identified. So let's go back to database, right? We know that a database is basically a collection of related tables, right? And these tables store records that are also related. Or records, or what we would also refer to as a row, consists of several fields. The fields are basically attributes of an entity. So for example, as what is stated in the table, your fields would be in the farmer's table ID number, first name, last name, just the name of you, and in your farm table, farm ID, crop, cost per produce, and farmer ID. So the question asks, in the database table farm, name the field by which each record can be uniquely identified. And this is referring to the primary key. So we know that a primary key, right? Your primary key is the key, right? Your primary key, a key that we can use to uniquely identify each record. With that being said, when we look at our table in farm, we're going to look and observe to see which piece of data is unique to each row. And remember, your row is also what we would call the record. So we have in our farm ID, we have 002, 192. In crop, we also have the different types of crop, cost per produce, and then farmer ID. However, we're looking at the data that is unique to each row. In this case, the data, or sorry, not the data, but the field would be the farm ID. So our primary key that we would use for a farm table is our farm ID. So the other question states, state the fields that must be linked in order to create a relationship between the two tables. We've already outlined that the farm ID is the primary key in our farm table, right? And in order for us to create a relationship, we need a common attribute or a common field. An attribute and a field, that's the same thing. So we need a common attribute and a common field. So when we look at our table and we look at the data, it's safe to say that the common field that we would need to create the relationship between the two tables is our ID number from our farmer's table and our farmer ID from our farm table. In this case, the ID number in the farmer's table, right, is what we would call the foreign key. So a foreign key is basically a key that is a primary key in one table. However, when it's placed in another table, it becomes a foreign key and can be used to create a relationship between the two tables. Again, in order to create a relationship between two tables, you must have a common field. The other question states, complete the design view extract below to show a simple query that will list the farmer's full name, region, crop, and farm ID for farmer ID number 1. Right? This is basically asking you to create a query. So usually when you're doing practicals and you go into Microsoft Access and you go into the query design view, right? You get all this little interface that you see here where it asks you for the field, the table, sort, show, criteria. So what you're supposed to do, they've presented you with the interface just as what you would see in Microsoft Access. This is the same interface that you would see in Microsoft Access. So whichever field is requested, you're going to state the field here in the first row. So they've asked for the farmer's full name. Of course, the fields that are presented to you are first name and last name. So we would place them back just as is as they were presented to you in the table. So we have first name, and for table, you're going to state which table the field is coming from. In this case, it's coming from the farmer's table. We have last name, and it's also coming from the farmer's table. We have region, and region comes from the farmer's table as well. We have crop, and that comes from the farm table. We have farm ID, and then we have our farmer ID. So again, remember that a query is basically an object that allows you to extract some form of data that meets a set criteria. In this case, we were asked to extract or to create a query to extract the records with farmer ID number 1. So this is the interface that you would have been given when you open Microsoft Access if you were doing a practical. So these boxes here, so you have sort, we're not requested to do any sort. We're asked to show the specific data. So every piece of data that you were asked to show, you're going to tick that box. So we want the first name, we want the last name, we want the region, we want crop, we want farm ID, and the farmer ID is what we're supposed to use to set our criteria. The criteria that was given was the person with farmer ID 1. So we're going to put 1 right here where we have criteria. So that is telling the software that, hey, any farmer ID where you see 1, I want you to pull that record, right? So this is how your query would look. The other question basically asks you to state the result of the query. What happens when you check back the table that is given around here, so you would make reference back to your table that was presented to you before the question, and then you would check to see which farmer ID is 1, right? And you would look at the names, first name, last name, the region, the crop, and the farm ID as well. So you're being asked to show, because we've already used the farmer ID to spec the criteria, we move right along to show the result, which would basically be first name, last name, region, crop, and the farm ID. So when we look on our table, the person who meets this criteria with farmer ID 1 is Jack Smith. So we would put all records for Jack Smith because he is the person with farmer ID 1. Region 1, the crop is banana for the first record, and the farm ID is 002. Again, there is also a second record, Jack Smith again, because he's the only one with farmer ID 1, same region, which is region 1. Crop is orange, and it's coming from farm ID, which is 192. So this would be the interface for your query, and the criteria was farmer ID should be 1, and you want all this information here to be displayed, and this would be the result for your query once the data has been extracted. So you would end up with 2 records. All right, so let's move on to our next question. So as I stated prior, we'll be looking at a series of questions. We just brushed on a database question. So now we're going to jump to a problem-solving question. And I mean, how can we not look at problem-solving and not look at the steps? So our first question states, having met with the Chief Technical Officer for Manufacturer X, the programmers/designers will finalize the problem-solving process. Place each of the following problem-solving steps in the correct order. 1. Define the problem, develop the algorithm, propose and evaluate solutions, test and validate the solution, determine the most efficient solution. So what is a problem? So we know that a problem is basically anything that prevents us from achieving our goal, right? So with that being said, the first step in our problem-solving process is to define the problem, right? Our first step is to define the problem. But what happens at this step? So we have what we would call our defining diagram, right? That we would usually use at this step, which is to define the problem, which is also what we call step 1, yeah? So another name for our defining diagram is an IPO chart. Our IPO chart basically allows us to break down the problem and outline the different parts of the problem in terms of its inputs, processing, and its outputs, right? So 1, we define the problem. Our second step is to evaluate all possible solutions. So you've now outlined the problem. What are all possible solutions that you can come up with for this problem? So after looking at each solution, of course, you're going to select the best solution or the most suitable, right? So select the most suitable from the list. After you've selected your most suitable solution, you're now going to write your algorithm. What is an algorithm? So we know that our algorithm is basically the sequence of steps that we would use to solve our problem, right? And remember, there are 3 ways that we can represent our algorithm. 1, flowchart. 2, narrative. And 3, a pseudocode, right? So 4, we write our algorithm, right? And then your final step is to test and evaluate. So our 5 steps, problem solving steps. 1, define the problem. 2, outline all possible solutions. 3, select the most suitable solution. 4, write the algorithm. And of course, 5, test and evaluate. We're now going to look at our next question that states, complete the paragraph by inserting the most appropriate terms in the blank spaces. So the values that are changeable during the execution of the program are known as, and of course, these are our variables. And the values by the programmer that will never change during the execution of the program are known as constants. So just a little reminder, remember your variables change throughout the program, and a variable can only store one piece of data at any given time, right? Your constants, so for example, a variable could be num, right? So num would basically take a number, one number at any given time. When you say num is equal to something else, it will basically remove what is already stored there and replace it with that new value. Your constant now, your constant never changes. Once you declare that a placeholder is a constant or a storage location is a constant, it remains the same. So for example, pi, we know that pi always holds a value of 3.14. So once you declare that pi is equal to 3.14, wherever you want to use the value 3.14, if you had a program where you were required to use pi, instead of putting the value 3.14, you'd put the name of the constant, which would be pi, pi, right? All right, so our next question, complete the following algorithm snippet to show the payroll process for manufacturer X. So the first thing that you do, you look at your pseudocode. This is a pseudocode, of course. You look at your pseudocode and you basically become familiar with it, right? So we have some constants that are declared here. We have our rate, which is equal to 5. We have the expected work hours, which is 40. And we have overtime rate, which is 6. So all we're doing is looking at it, and this is a selection statement, right? This is a pseudocode with a selection statement in it as well, which is an if, then, else. All right, so let's go. So we've gotten to the work hours, and we're supposed to test to see if the work hours is greater than the expected hours. Or expected hours stated was supposed to be 40, right? So we've gotten our work hours and we say read hours worked. Now we want to test to see if the hours worked is greater than 40. Remember, 40 was already stated as the expected hours, and expected hours was declared as a constant. So we say if hours worked is greater than, so remember this is a greater than sign. And I'm not going to put 40 here. Why? Because remember in our previous question, we spoke about variables and constants. Expected hours was already declared, right? And we already saved the value 40 in expected hours. So instead of putting 40 there, we're going to put expected hours. So if hours worked is greater than expected hours, then remember what we put here is the action that we take if this condition here is true. So for example, if I work 50 hours, that means that 50 is greater than 40. So this is the action that I would take, which is to calculate the overtime hours as well as calculate the overtime pay, right? So let's go ahead. So overtime, and if you have any questions, you can post them in the chat as well. So overtime hours would basically be equal to the hours worked minus the expected hours. And you realize that I'm keeping my variable names constant. I don't change my variable names. So overtime hours is equal to hours worked minus expected hours. And then after I get the overtime hours now, I want to calculate my overtime pay, right? And my regular pay in order to get the pay that I would receive, which is to add the overtime pay plus the regular pay. So we're going to say pay is now equal to, and our first working out is to calculate the overtime pay, which is the overtime hours that we just found right here, times or overtime rate, which was already declared at the top, which is 6, right? So we wouldn't put 6 because the rate is already declared. The rate was already declared as a constant and it holds a value of 6, right? So that's overtime rate. So overtime hours times overtime rate. And then this would have been added to the regular pay that they would have gotten, which is the expected hours times the regular rate. So that would be the overtime hours times our overtime rate, right? And then our expected hours times the regular rate right here. And that is how we would get our pay in addition to the overtime pay that the person would have gotten. So that's only if this condition is true. Now we have our else. What if it's not true, right? So we need to add our else, which would now be, so if the person didn't work any overtime, they'd basically get their same regular pay. So the pay would be equal to, and the back arrow means the same as equal, expected hours times or regular rate. And of course, end if to end the if statement. And that's basically it. All right. So let's look at our next question, which they asked us to represent same pseudocode using an IPO chart. So remember, I would have outlined how we can represent algorithms, and this would have been the pseudocode. So they're now asking us to represent the same algorithm using a flow chart, right? So we're now going to construct our flow chart. So let me just erase the board. And just to make it easier for you, just remember, when you're doing your flow chart, it's basically like you're taking the lines of codes from your pseudocode and placing them in their respective symbol, right? So you have your start, and you place a start in your terminator, or your start-stop symbol. You have your input-output statement, you place it in your input-output symbol, and so on, right? So we're now going to construct our flow chart for the respective pseudocode that we just looked at. So we start with our terminator, or start-stop symbol, and we have our start. Our assignment symbol now is what we have here. And once you initialize a variable, once you declare a constant, you use your assignment symbol, right? So we have rate, and these were all given to you in the pseudocode above. Then you have expected hours, and then you have overtime rate. The next step that they have in the pseudocode was to read the hours worked. So we use our input-output symbol, which is this symbol that we have here. So we say read hours worked. So after we say read hours worked, just like in our pseudocode, we would need to decide whether or not the hours worked is greater than the expected hours worked, right? So at this point, we would need our if statement, but we don't just write the if statement like that. We use what we would call our decision symbol, right? So we would put our decision symbol, and what we would do is to place our condition in our decision symbol. So in this case, the condition that's given is if hours worked is greater than expected hours, and we have two branches. We always have our yes branch and we always have our no branch, right? So, or if it's an if then, we would usually have our action on our yes branch, and then the no branch would usually remain empty, and then it goes, it goes to the stop, right? But once we have an if then else, we need to have the actions for our yes branch and also for our no branch, so our no branch cannot remain empty, right? So we need to label our branch, and we're going to first look at our yes branch. So if I worked more than the 40 hours, this is what I'm supposed to do. Or overtime pay is supposed to be calculated just like what we did in pseudocode by saying, and again, we use our assignment symbol. So overtime hours is equal to hours worked minus expected hours. Right? And we have our pay now is calculated as the overtime hours, which we just found up here, times the overtime rate. But we don't stop there, right? Remember, this would just be the overtime pay. This is supposed to be added to your regular pay, which is the expected hours times the rate. And this would be for yes branch. We need to complete our no branch now. So if not, and we just worked our regular hours, we have our assignment symbol again, and we say pay is now equal to expected hours times the rate, which is the regular rate, right? Or flowchart is not finished. So I'm just going to use a connector to connect both symbols right here, and this is our connector here. And then remember, our pseudocode must have a start and a stop, and I place my stop in my terminator or my start stop symbol, and this would basically be the respective flowchart for the pseudocode that we just looked at. So we have our start, we have our assignment symbol, we have our input-output symbol, we have our decision symbol, which is for our selection statements. We label our branches. So we have our yes branch and we have our no branch here. We have our actions to take if the condition is true. We have our actions to take if the condition is false as well. And of course, once that is done, we go to our stop, right? And that is how we represent the flow chart for the given question. All right, so let's move on to a spreadsheet question. So the logistics hub has created a spreadsheet to track the number of containers that pass through its port for different shipping lines. So again, you look at your spreadsheet, just like how you look at your database tables, and you try to understand the data that is presented to you. So in this case, this is a logistics hub, right? So you have different shipping lines, and they seem to ship from Mondays to Saturday, and a fee is charged. So if you look in cell A8, you're going to see it's been labeled total. If you also look into cell H2, it's labeled total as well, right? So remember your column headings, those are also what we call our fields, and then your rows run from left to right, right? Those are what we also call our records, right? So the first question states, state what formatting feature was applied to the spreadsheet image above. So if you look at it and you look at it carefully, you can see that several of the headings are bold. If you look at logistics hub, it's bold. If you look at shipping line, Monday, Tuesday, Wednesday, right across, those are bold. And if you look at total, that those also have been bold. But also look at logistics hub. You realize that it's a bit centered across on the spreadsheet? Yes. So it's not merged. It's not center. The answer is the logistics hub was merged and centered, right? So not just merged, not just center. It was merged and centered, right? So it's merged and center, which can also be one of your responses, as well as bold, which was applied to several of the headings. The data in the spreadsheet is sorted. State the column on which the sorting feature was applied and the sorting order, and that is 2 marks. So you look at your table, you look at your spreadsheet, you look at the data presented in front of you. In this case, the field by which the spreadsheet was sorted by was the shipping line. And if you look at it, you have B, C, G, K. It's safe to say that the table was sorted in ascending order, which is from A to Z, right? And we know that we also have our descending order, or from highest to lowest, right? Which is also descending order. But in this case, it's from A to Z, as well as lowest to highest, right? So it's a shipping line. Write the formula/function to be inserted in cell H3 to calculate the number of containers shipped during the week for Canva shipping. All right, so let me just step away from the actual question and let's discuss functions and formula, right? So if you see formulae, it's basically the same. It's just that it's the plural of formula, right? So formulate, the plural of formula. Or formula is basically an expression that returns a value. Or function is a predetermined formula. So, or formula is an expression that returns a value. So for example, equal A1 plus B1. That's a formula. However, our function is a built-in predefined formula. So for example, your sum function, your min function, your max function, your average function, those would be functions, right? Predefined. So when you're using any of those, you put equal sum, equal average, and then you state your range, right? In this case, the question asked you to state either or, right? So it says write the formula or function to be inserted in cell H3 to calculate the number of containers shipped during the week of Canva shipping. So let's look back on our table. This is H3 right here, right? But let us just look at it. It asks for Canva shipping However, canvas shipping is in row 4, right? So if they were truly indeed referring to canvas shipping, it would have been H4. But what we would put in H3 though, which is for blue C line, is our formula would basically be, because it asks for H3, we're going to use H3, but that's for blue line and not canvas. So our formula would have been equal, and remember, every function or formula starts with an equal sign, right? So B3 plus C3 plus D3 plus E3 plus F3 plus G3. So we're basically finding the sum of all the cells going across for the blue C, right? And if we were writing the function, this would have been our function. Equals sum, and then the range of these, which is the starting cell address and the ending cell address, right? So that would be sum equals sum B3 colon G3. And I hope you're seeing the difference in all this. So this is our formula and this is our function. And every function or formula begins with an equal sign. All right. So the next question asks, write the function that would be used to determine the lowest number of containers shipped on Wednesday. So we were asked to write the function. So not no formula, no, function. So of course we have our max function, which would give us the maximum value. We have our average function, which we use to find the average. So of course we also have a min function, right? Which can be used to find the minimum value. So in this case, we look back at our table and it asks for the lowest for Wednesday, right? So we also look for our range, which would be D3 to D7. So with that being said, our lowest number, the function that we would use, would have been equal min, because it's the minimum value that we want to find, D3, which is the starting cell, and the ending cell in the range would be D7. And that is how you would write your function to find the lowest number of containers shipped on Wednesday. All right, we're now going to move on to a spreadsheet question, right? And the first thing that you're asked to do, state the type of chart used to represent the data in figure 1. So you look at your chart that's presented in front of you. So of course you have to be familiar with the different charts. So you have your bar chart, you have your pie chart, you have your all of those, right? So in this case, the chart that is presented to us is a column chart, right? So this chart right here is what we would call a column chart. The next question we're asked to do is to list the steps that we would use to basically generate our column chart, right? So of course, the steps that we would use is to first highlight the required data that we want to represent on our chart. So we highlight our required data that we want to represent on our chart, right? Because if you don't know what you want to represent, how are you going to generate a chart? So you highlight the required data. And this is basically the range for the data. In this case, it's A2 to G7, right? So you look on your table, which is presented to you before, and it is A2 to G7. So it says, go to the insert. So of course you go to your ribbon and you look for the insert tab, and then you're going to go to the insert tab, and then you select the type of chart that you want. So 1, 2, go to the Insert tab, and then you go to Chart, and you select the type of chart. And in this case, it's a column chart. All right? So after you've selected the type of chart that you want, right? You choose your design, whether it's 2D or a 3D design. You also label, right? So you choose your design, whether it's 2D or 3D, and you're going to label your chart. So you label your axis, and you give it an appropriate title, right? And of course, I'm sure from the look of it, once we look at this chart here, right, we can see it has an appropriate title at the top, the logistics hub activity by week. We can see our axis being labeled, shipping line. We can see our legend at the side, Monday, Tuesday, Wednesday, and what represents each day, right? So without all of those, your chart would basically be incomplete, right? So your steps also have to be complete in order to get whatsoever you have presented here. All right, so another problem solving question, right? So we're just zeroing in on problem solving or productivity tools, spreadsheet, database. So complete the table by inserting the data types to be used for each of the following variables. So let's go back to variables again. So remember, variable is a memory location and it changes throughout the execution of the program, right? So yes, our variable has a name, but your variable also has a data type. What is your data type? Remember, your data type tells you what can be stored in that variable. In terms of, if it's a name, we know that the data type is going to be string, because of course it's going to be taken in text, right? A collection of characters. So first name in this case would be a string. Item price, of course, it's money. So naturally, we're going to say money, we represent them as decimal. So we would declare this, or we would say that the data type for item price would be real, right? Real or float, which is what we declare decimal values as. We have receipt number, and receipt number would basically be integer, right? So you're just looking back at what you have there. And then we have in stock, whether or not the item is in stock, that would also be integer. Integers are basically your whole numbers, whether they are negative or positive. There was a question before that, and that speaks to syntax error. What is a syntax error? So basically, we know that an error is basically anything that doesn't go well, right? In programming, we have different types of error. One that's presented here is syntax error. So your syntax error is any error that goes against the programming language. It prevents it from running. So we've been talking about variables all along, and at one point earlier I mentioned, you realize that I'm keeping my variables consistent because this is an example of a syntax error. If I have hours worked, and then I have another variable name, hours underscore worked. Are these the same variable names? No, they're not, right? One is hours worked, while the other is hours underscore worked. Two different variable names. So if this was an actual program, I would get a syntax error. Your syntax error prevents the program from running, right? So your syntax error prevents the program from running. The other question that we're going to do, also a programming question. The pseudocode below will calculate and output the number of participants and the average age of all participants attending the ICT symposium. The algorithm will terminate and display the output when an age of 999 is entered. You probably might be thinking to yourself, 999, but nobody lives that long, right? 999 in this case is your sentinel or your terminating value for your loop. If you look further down in the question and if you look at the question itself where you're going to be filling in the blanks, you're going to be using a while loop. So in our while loop, we have what we call a sentinel value or a terminating value, which is what you would enter to basically terminate the program or terminate your loop rather, right? So complete the following pseudocode by filling in the blank space labeled 1 to 10. we set average to total divided by count. And as I was saying before, why total divided by count? Remember, I stated earlier, our loop is an indefinite loop, which means that we are not sure how many times the loop will run before the person has decided to enter 999, which is the sentinel or terminating value to stop the program, right? So in order to keep track of the number of times that the loop runs, we add the value count, and it basically accumulates. So every time the program runs or every time the loop runs, one is added to count, right? So this will keep track of the number of times that the loop runs, and then we will divide that into total in order to return the average age, right? So again, before we end the loop, we always want to request for a piece of data. And how do we do that? We have to prompt the user again to actually enter another age. And we do that by saying, right, enter another age, or 999 to terminate the program. I know you're looking and you're saying, why we have write down here, so, and then up here, so we have print. It's the same thing, right? Print, it's the same thing, right? It means the same thing. They're both keywords that represents output, right? Just like read, accept, both keywords that represents input, right? So we have write, enter the age, or 999 to terminate the program. You say informing the person that they can enter 999 to terminate the program is actually making your program more user friendly, right? Because the person does not need to spell and guess what they need to enter to stop the program. It was clearly outlined in their prompt. So after you get the data, yes, you're going to read age, right? So we read age. So we've accepted the age, and then once you get that, it's all, every time you get an age, it's tested to see if age is not equal to 999, right? And then remember, every time you get the age, it kicks out whatsoever is stored in age, and then it's going to be added to total, which allows whatsoever is being stored in total to be kicked out and replaced with the new value, right? And then count goes again, and 1 is added to count again, right? So it just keeps building up, it keeps increasing. And then the average is found where we say total is average is equal to total divided by count. Then we prompt for the age again, and we test. So let's say yes, the age has been entered and 999 was entered. That means that, okay, I want the program to stop. Then I go write end while, which is to end my while loop. And then I want to output now the number of participants as well as the average participants. So we say, right, the number of participants are, right? And remember, I stated that count was already keeping track of how many times the loop will run, which means that that's the same number of ages that we got. So what am I going to output here? Count, right? Makes sense. All right, so we say the number of participants are, and a close quotation, comma, count. And then we have write, which is the same as print, the average age of participants are, use quotation, comma, and of course, average. But our pseudocode is not finished, you know. Remember, every pseudocode has a start and a stop. And that would basically be how you would complete your while loop, your pseudocode to fill in the blanks. So I think that is about it as it relates to problem solving and what we will cover for today. If you have any questions, any shout outs, I hope you send them in the chat, and enjoy the rest of your evening and happy holidays.